Hey everyone, so in this brief video, I'm going to show you how to use Microsoft Excel to create a line of best fit on a scatter plot. And so we're going to be able to see how well you did yesterday when you did your line of best fit by hand. And we're going to see how we can actually leverage technology to be more accurate and to save us some time. So before I started this video, I opened up a blank Microsoft Excel workbook. And I created a table that has all of my input and output variables. All of my X or input variables are listed down column A, and all of my output or Y variables are listed down column B. And I'm going to use a scatter plot to try to determine whether or not I think there's a relationship or a correlation between height and weight. So the first thing that I'm going to do once I have input my data, and if you're still inputting data, definitely feel free to put pause on this video while you do it. I'm going to highlight by clicking in the middle of the height box here. And without letting go of my mouse, I'm going to drag down and highlight all of the data. It should turn light gray. And once I've highlighted the data that I want to use, I'm going to go up to the top menu and I'm going to click Insert, and I'm going to insert a scatter plot. And almost immediately, a scatter plot's going to pop up on my screen. Now, there's different ways we can format our scatter plot. Up top, we're going to start getting all these fancy, fun little options. None of that really matters to me. You can do whatever you want with your scatter plot there. We're going to do some important things right now to our scatter plot because it's not quite ready to be handed in yet. So there's some things that we want to be able to do with Microsoft Excel. The first thing that we're going to want to do is we're going to right click on the bottom here of our axis. Actually, we're not going to do that first. Let's do this first instead. We're going to go up to the top and click Add Chart Element, and we're going to add a primary horizontal and a primary vertical axis title. And along my x-axis on the bottom, that title for that axis is going to be, in this case, height in inches. And my primary vertical title or y-axis title is going to be weight. And my unit here was pounds. And my title for the entire graph, my entire chart, is going to be something along the lines of relationship between height and weight. Okay, I'm going to go ahead and make my title here a little bit smaller so it fits on my top line. Okay, so the next thing that I'm going to choose to do here is I'm going to right click on my chart. And as I right click on my chart here, I'm going to say I want to format my chart area. Okay, and there are options here for different things we can do to play around with our chart. So we can change the chart background and change the little shape that we make all the little data and all kinds of stuff like that. Again, it's not something you have to do, but there are a lot of options available to you right there. The next thing that I would like to do, let me go ahead and click on this, is I'm going to format my axis. So I right-clicked on my x-axis and said format the axis. And this is not something we have to do, but it's something that I like to do because all of our data is very bunched up on this side of our graph over here. So I'm actually going to say that I don't need our height to count from 0 to 80. My minimum is really closer to 50. So I'm just going to count my height from 50 to 80. So I'm going to enter 50 there instead. And that's just going to help kind of center that data a little bit, spread it out so I can really see the trend line when it comes time to put that in. And we could do the same thing for weight potentially. So we could right click on format axis on the weight axis. And the smallest weight I might need is something in the 80-pound range. So we could really kind of spread that data out by changing our axes. That's not a requirement. It's just something we can do if we want those data points to spread out a little bit more. The more important thing and most important thing that we're really going to use Excel to do here is to estimate our line of best fit and our correlation. So if we right click on one of these points, they all kind of get highlighted. And if you right click on one of them, one of the options we get is something that says add a trend line. And I'm going to click on add a trend line. A trend line is another word for a line of best fit. In our trend line options, we want to make sure that we're using a linear trend line here. So we want to make sure linear is clicked. And down towards the bottom, we want to click on the last two boxes here. One of them says display the equation on the chart. When I click on that, what happens is the equation, my y equals mx plus b, pops up on my chart. And the other box down here says, let me click that off for just a second, go back to this trend line. The other box says display the r squared value. And we're going to talk about r squared value in just 1 second. Those are the two things that Excel has now calculated for me pretty quick and easily. I didn't even have to do any of that math. This equation is something we're going to want to pay attention to because we're going to hope that this equation is pretty close to the one that you came up with by hand. If you drew a pretty good line of best fit, then you're going to have a pretty strong equation. This r squared value is related to our correlation coefficient. So if you recall, when we talked about correlation coefficients, we said that they were going to be a number between -1 and 1. And that represented -1 or 1 would be a perfect correlation, a perfectly straight line. 0, kind of right in the middle, would represent no correlation. The way that we turn an r squared value into an r value, or a correlation coefficient, remember that correlation coefficient is the letter R. Well, the only thing we need to do to find our correlation coefficient, love when we autocorrect to symbols that I didn't intend us to use. The way that we're going to find that, given that we were given an R squared, is we're going to take the square root of that number. So I'm going to pop up my calculator really quickly. Jump my calculator up on this screen for us for a second. The R squared value is 0.7821. And if I want to know what the R, or correlation coefficient, is, all I need to do is take the square root of that number. So I'm going to go in, oh, that's wonderful. Our calculator on here doesn't have a square root. Fantastic. So I'm going to do a little trick. If I can't find it in here, let's see, in our functions. No, it's not there. So I'm going to raise it to the power of 0.5, because that's the same thing as taking a square root. Since they're not giving us the option here, your calculator probably has a square root button. We're going to take the square root of our correlation coefficient, and that's going to be our correlation, our r squared. If we take our square root of our r squared, we're going to get the correlation coefficient. In this case, it's 0.884. And you know what words we've used to describe a correlation coefficient of 0.884. First of all, it is positive, and that's because our line is going up. And second of all, it's pretty strong. 0.884 is getting pretty close to 1. So this is a pretty strong correlation. With a correlation coefficient of 0.884, with a strong correlation, I can probably make a conclusion here that there is in fact a relationship between height and weight. Remember, when we talk about correlation, we're not saying that one causes the other one to happen. We're not saying, for example, that if I take a person and stretch them out to make them taller, that they're going to get heavier. We're not saying that if we feed somebody a bunch of Oreos and they gain weight, they're going to get taller. One is not necessarily causing the other one to happen. Correlation simply means that the two things are related. It tends to be that taller people weigh more. And that is backed up by the fact that the correlation coefficient was 0.884. If we got a correlation coefficient of 0.6, we might say that there's a moderate correlation, so there might be a relationship between two things. If we got something like 0.2, we're almost at 0. We'd probably make a conclusion that the two variables weren't very related at all. But with a correlation coefficient of 0.884, we can conclude that height and weight are probably related. And there's probably a reasonable relationship between height and weight. Before I end this video, I want to talk about one more tool, and that is the snipping tool. If you're not familiar with it, those of you that are on PC, there is an equivalent on Mac as well. We can use the snipping tool. If you look on your bottom search area and you search for the snipping tool, it looks kind of like this. And the snipping tool is going to be the fastest way for us to say, I want a new picture and I want to grab this. So you're going to need to be able to grab a picture off of this page to submit your assignment today. So I would like you to make sure that you are familiar with the snipping tool. Last thing before we go, just want to reiterate one thing, because I think the most confusing thing in this whole video is going to be finding this correlation coefficient. We do that by looking at the r squared value and then finding the square root of that number. The square root of 0.7821 is 0.884, and that is our correlation coefficient. If you have any questions, please let me know, and best of luck working on Excel today and finishing up your math in action for this week. Bye.